Good evening. This is VK3EKH, VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast, coming to you from the studios of VK3CSJ in Narre Warren South. A very pleasant good evening to everybody that's tuning in at this time of the Friday night. We're broadcasting on prime frequency of 3541 kilohertz in the 80 metre amateur radio band, and also on the Melbourne television repeater, VK3 RTV, digital channel 1. Good evening, viewers. And also on my two HD streams on YouTube, just type in VK3 CSJ and look for the live indicator for the YouTube feed, and also on Discord. As I say every week, if you're not on Discord, just to go to Discord, type in Discord in your favourite search engine and register. And don't forget your password that you create. And then go to qrz.com and look for my call sign, VK3CSJ or VK3EKH. And on the qrz.com page, I provide a URL which allows you to access the astronomy chat room, which is where also the HD stream is. I recommend Discord from the point of view that the video delay is less than a second compared to YouTube, which is anything up to 20 seconds. But some folks don't mind the delay if you're listening to me live here. That's fine. Anyway, we're streaming on the internet on those two mediums, and also via the TV repeater. I always suggest that this is why I provide the video channels, because there is a certain amount of video information that's associated with the broadcasts that I do. For instance, tonight we have a video or a session from the space weather woman, Tamitha Scove. She goes for about 16 minutes in tonight's session, just released a day or so ago. So that's very visual, more ways than one. Welcome to tonight. It's already 4.1 degrees here in Narre Warren. So she's a nice chilly night. All right, let's get into things. We have a few things tonight, but hopefully won't run over time like I usually do. As far as people tuning in for the first time to the ASV, to the broadcast, just briefly, well, as brief as I can make it, with a bit of fun thrown in. The Astronomical Society of Victoria, founded in 1922, comprises well over 1,600 members throughout Victoria, Australia and overseas. Membership of the Society is open to all persons with an interest in astronomy. The Society's objectives are to encourage the study and practice of astronomy, and to disseminate knowledge of the science, and to provide greater facilities for the study among its members. Monthly meetings are usually held on the second Wednesday of each month, which was just last Wednesday, in fact, the Wednesday this week. Meetings start at 8 p.m. at the Mulia Hall. If it's going to be held in Melbourne, it'll be held at the Mulia Hall, or the National Herbarium, Burwood Avenue, Melbourne, near the Melbourne Observatory, which is located not too far from the Shrine of Remembrance. Parking is available in Burwood Avenue, Dallas Brooks Drive and the surrounding streets. Admission is free, and visitors are most welcome on these monthly meetings. Usually they aim to finish the meetings by around about 10 o'clock, and there's free cups of tea and coffee with some bickies. If I assume that they're still doing that. Privileges of a membership include the right to borrow books, periodicals and other publications from the Society's extensive library located at the Melbourne Observatory, receipt of the ASV magazine Crux, containing articles, news, observing notes and the like, and the free provision of the Astronomical Yearbook. Access is available to telescopes on members' nights held regularly at the Melbourne Observatory and after the monthly meetings, weather permitting. These instruments include the Society's 300mm equatorial reflector, a 300mm portable reflector, and there's also a 200mm refractor which is managed by the Royal Botanic Gardens, and a photoheliograph are also housed at the observatory and are accessible to members as well. The Society has a number of 200mm reflectors available for short period loan, so members can try before they buy, sort of thing. The regular Society Club Night meetings are held at the Melbourne Observatory in the Ellery Suite, Burwood Avenue, opposite the Shrine of Remembrance. Members are encouraged to use the Society's instruments located there in order to gain first-hand experience in telescope use. These instruments include a 508mm equatorial reflector and a number of smaller reflectors. Members are also encouraged to make use of the Society's country property located near Heathcote, about 90 minutes drive north of Melbourne. There are a range of instruments available for members to use, the larger two with appropriate training, and they range from 300mm to 1000mm in aperture. Also located on the site is a 8.5 30-footer fully steerable radio telescope, a DS Kennedy dish, which members can get involved with through the radio astronomy section of the ASV. Members are also encouraged to make and use telescopes. Advice and help on both matters are provided willingly to newcomers wanting to do the same. Instrument making is only one of the number of common interest activities catered for within the Society. Other areas of interest that members can participate in include deep sky observing, astrophotography, lunar and planetary observing, auroral, meteor, comet, radio astronomy, computing, cosmology and astrophysics, historical studies and research and astronomy in general. Contact details for various section directors can be found in the yearbook or on the website. Further information may be obtained by visiting the ASV website, and notifications of events are given in the Crux Extra Bulletins. The Crux Extra Bulletins are a regular email to members which get released every week or every second week, just to keep members informed of what's going on. Please note the ASV will conform to all government health directives, thus ASV events may be required to be cancelled, moved or postponed. If you wish to write a letter via the normal post, the mailing address is the Secretary, Astronomical Society of Victoria, GPO Box 1059, Melbourne, Victoria 3001. Otherwise, you just can visit the ASV website at www.asv.org.au and all will be revealed. You're tuned to ASV Radio VK3 EKH, broadcasting on 3541 kilohertz. We've been operating since 1988, not necessarily me, but the little volunteer type service that this has been going since 1988 under the call sign VK3 Echo Kilo Hotel. Look it up on qrz.com. All right, we'll see you all next week. Oh, look, the picture on the repeater's gone funny. Oh, well, it'll probably come good in a minute. I'm not sure why that is. I'm not too worried about it at the moment, but the video picture on ATV has gone a bit funny. It looks like a weak signal into the repeater, which is a bit strange. That's not good. Anyway, we'll monitor that. Meanwhile, YouTube and Discord run fine. I'm running 20 watts on RTV, so the power output is fine. Let me just check that SWR quickly. Oh, it looks all right. Yeah. Yeah, there might be a bit of moisture in the air. All right, continuing on, we'll keep an eye on the repeater. It might come good. Hopefully it will. I don't think I need to reset it, the system. It's usually just a poor signal. All right. Now, next on the cards is Now, last Wednesday was the Astro Talk. Now, the last Friday, I wasn't too sure who they were getting to do the Astro Talk. But I can see the calendar was updated at some stage this week, or possibly last weekend. Anyway, we had a very, very interesting presenter. His name was Ben Sorensen, and as it says here on the calendar, it says, after much discussion, we're excited to officially lock in Ben Sorensen, the consortium director of ELO2, not Electric Light Orchestra, but it's to do with our lunar rover, or RUVA, as in kangaroo, Australian, for an exclusive talk on the Australia's lunar rover. In fact, while I'm just mentioning that, I can run a quick video. Where is it? Where did I put it? There it is. I'll make sure that's muted. Let me just run it first.
Expertise in...
And I'll just mute that. All right. Okay, so the video is running right now. This is his presentation. It's like a PowerPoint thing, but anyway, you can on the screen right now, apart from the TV repeater, is a picture of what the moon rover will look like, or the RUVA. Anyway, going back to the information here that's available. So Ben Sorensen, Consortium Director of ELO2, for an exclusive talk on the Australia's lunar rover, or RUVA. Ben will be sharing the story behind RUVA, the mission goals, and what it means for Australia's future on the moon. From the engineering challenges to the broader vision of ELO2, this is a rare chance to hear directly from one of the key figures shaping our lunar future. Don't miss this deep dive into one of Australia's most exciting space projects. So that was last Wednesday, and it is available because it was streamed on YouTube, because it's naturally recorded, and the president of the ASV, Mark Sicario, has made the video available to view. So if you all go across to YouTube right now and type in Astronomical Society Victoria, you'll see the presentation that was done last Wednesday, and you can sit there and just listen and watch what Ben talked about. It is really fascinating stuff, and I really hope, with fingers crossed and toes crossed, that when they do launch this RUVA, little rover probe to the surface, to the South Pole of the moon, that it will go 100%, no problems at all. You know, it's always a 50-50 thing. it's the chance of having success with landing on any celestial object is always hit and miss. But if you get it all right, it'll work. So yeah. Anyway, I've got an alarm going in the background here. That's not a good sign either. That if I hear that alarm, it tells me that I'm drawing over 40 amps on the mains, which means that our circuit breaker could trip. And if everything disappears, honestly, if everything disappears, that's it for tonight, okay? My circuit breaker on the switchboard is only good for 40 odd amps, and I constantly monitor my current draw, and if it draws anywhere near 41, 42, it beeps. It's in the kitchen. I can hear it. It's not beeping now though, but it just goes to show that a couple of split air conditioning systems here just to warm this place up is just drawing a little bit too much current when they cycle on. That's just okay. Now I've got no signal. I'm looking at the TV repeater and there's no signal there at all. It's just like I've dropped out of the repeater altogether. So apologies for anybody watching ATV. I don't know why I've dropped out of the repeater, but that's the nature of RF. And I don't know if there's any moisture in there. I don't think it's raining in Melbourne, so I don't believe it would be a rain cloud anywhere. Don't know. Anyway, my recommendation is Discord or YouTube. Oh, I forgot to mention the email address, vk3ekh@gmail.com, vk3ekh@gmail.com, and that'll be fine. For any signal reports, and I'll just take a quick look at that. Andrew has checked in. He says he's listening on 80 metres. It's a strength S59 signal. A little noise on the band. It may be the aurora. And I think you're right, Andrew. There is a very good possibility of aurora activity tonight. I will be showing that image in a minute. In fact, I could probably do it right now. For those watching ATV, I mean the TV side of it, that's the current aurora over Antarctica. And look at that. There's lots of green, lots of yellow and red, or pushing its way up to the mainland. So yes, there is definitely aurora australis effects happening in the atmosphere as we speak. All right, back to camera one, and let's continue on. I was just going to quickly go over some of the sky notes from Dr. Tanya Hill, the astronomer at the planetarium. Sorry, Struth Solarium. Yeah, all right. Let me see. Actually, I'll just continue on with some of the on this day. I'm not sure where I got to last week. Pioneer 10 probably. On the 13th of, and today is the 13th, isn't it? Yeah, that'll do. I'll start it off on today's date. On the 13th of June, 1983, Pioneer 10 becomes the first spacecraft to travel beyond the planets of the solar system. Also on the 13th of June, 2010, Hayabusa, I think that's how you pronounce that, Hayabusa, in Japan. The craft returns the first asteroid samples to Earth. On the 14th, 1962, European Space Research Organisation, ESRO, begins, later to be part of the European Space Agency, ESA. That was the 14th of June, 1962. On the 15th of June, in the year 763 BCE, Assyrians record a total solar eclipse, which has helped in dating other events in the Mesopotamian history. Right. On the 16th of June 1911, a meteorite weighing in at 772 grams strikes a barn in rural Wisconsin, USA. Well, I live in a barn here, so I better be careful. I often wonder about that. I mean, there's always meteorites, particularly micro meteorites entering the atmosphere from all angles, and I often wonder about one of those penetrating the Colorbond roof, waking me up at 3 o'clock in the morning. This glowing meteorite in the bedroom floor. Anyway, also on the 16th of June 1963, Valentina Tereshkov, USSR of course, is the first woman in space in Vostok 6, the first civilian into space and the only woman to undertake a solo space flight. On the 17th the 17th of June 1969, Varuna 6, USSR, descends into Venus' dense atmosphere, sending data before being crushed by rising pressure. On the 18th of June 1983, Sally Ride is the first American woman in space aboard Shuttle Challenger. On the 20th of June 1990, asteroid Eureka, found as part of the Trojans asteroid group orbiting at Mars, L5 Lagrange point. So there's a bit more information needed there, I'd say. On the 21st of June 2004, Ship Shape 1, that's my dyslexia kicking in there. The 21st of June 2004, Spaceship One, USA, launched as first privately funded human spaceflight. Also on the 21st of June 2006, Pluto's small moon Nix and Hydra are named. 22nd of June 1633, Galileo recants his sun-centered solar system model under threat of torture by the Catholic Inquisition. And we all know what happened then. On the 22nd of June 1978, Dr. James Christie discovers Pluto's large moon, Charon. On the 24th of June 1883, discoverer of cosmic rays, Victor Francis Hess, is born. Also on the 24th of June 1915, birth of Fred Hoyle, who explained the creation of elements in stars, promoted the steady-state universe, and coined the pejorative term Big Bang for the rival model of the universe's creation or beginning. On the 29th of January 1818, Angelo Sacchi was born. Angelo Sacchi, I guess, one of the first astronomers to believe the sun is a star. 1818. 29th of June 1995, Space Shuttle Atlantis, first docking at Russia's Mir space station. 30th of June 1908, a meteor several meters in size explodes over Tunguska, Russia, destroying 2,200 square kilometers of forest in a multi-megaton blast. And also, finally, on the 30th of June 1971, Soyuz 11, USSR, was the only mission to visit the first space station, Soyuz 1, after which its crew of 3 became the only humans known to have died in space when their cabin depressurized prior to re-entry. So that's the dates for June, courtesy of Dr. Tanya Hill, the resident astronomer at Science Works Planetarium. Thank you, Tanya. And I can quickly show you a picture of Tanya just for a few seconds there. I've kept that picture there, haven't I? Yes, there she is. There she is. There's Tanya. And I don't know what's happened to the repeater, but it has disappeared. It is not. I've lost signals from VK3 RTV, so I don't know what's happened to the poor old repeater. But I am still transmitting, and I can see them doing pretty well, so it's always something. Anyway, you're tuned to ASV Radio VK3 EKH, where we present every Friday night the odd bits and pieces of news from the astronomical medium. All right, now we have something about Voyager here. I'll bring up this picture, just so you're not always on me. Okay, can either Voyager image our solar system from their current location? Can either Voyager image our solar system from their current location? Both Voyager's cameras have been turned off, but neither craft would see much even if they were still on. And it says here that after either of the Voyager spacecraft capable of taking a picture of our solar system from their current interstellar location. Oh, that's the question. This is the question being asked by a Jake Cunningham in Oregon. He's asking, are either of the Voyager spacecraft capable of taking a picture of our solar system from their current interstellar locations? ? And the answer is no. But let's talk about it. How the spacecraft that once dazzled scientists and the public alike with images of our solar system came to this state. To preserve power and memory, mission operators turned off all the Voyager cameras between late 1989 and early 1990 when they had wrapped up their tour of the solar system. Voyager 1 took the last picture, affectionately known as the solar system's family portrait, on February 14, 1990. While the spacecraft are still functioning today, most of their other instruments have also been turned off for the same reasons. Plus, in the depths of interstellar space, there isn't much to observe anyway. The spacecraft still have 3 functioning instruments, each built to measure cosmic rays, magnetic fields, charged particles, and plasma waves. The science that is valuable in otherwise empty space. A separate plasma science instrument failed on Voyager 1 in 1980 and was turned off in 2007, but it remained working on Voyager 2 until operators turned it off on October 2024. Mission operators expected the crafts to send at least engineering data back until 2036. NASA points out that even if mission control could turn the cameras back on, the computers and software that once would have analysed the data simply don't exist anymore. Furthermore, the years of radiation and cold exposure have probably damaged the cameras. Added to that, the Voyager's software is nearly 50 years old, and the operators are extremely cautious about sending any signals to the spacecraft, wary of inducing any errors in the antiquated system. And if the cameras were turned on, the dark space means that they wouldn't image anything in particular. The cameras were built to take pictures of big planets and their moons that gleamed in the sun's light as Voyager buzzed by. The spacecraft don't have telescopes, so anything they see would be merely a dim point of light. To put it in perspective, Saturn's orbits at a distance of 9.5 astronomical units, where an AU or 1 AU is the average distance between Earth and the Sun of 93 million miles or 150 million kilometres. Voyager 2, the closer of the twin spacecraft, is currently at 140 AU from the Sun, meaning you are 16 times closer to Saturn than Voyager is. So even if they could take a picture, your phone could take a much better one, and what a difference time and distance makes is what the editor says here. So yes, that's the latest on Voyager as far as being able to turn their video cameras back on again. You're tuned to ASV Radio, VK3EKH. Next on the list here is... yes. Okay, let me just bring up this image. And what we're looking at here is... on June 10, 1927 is the birth of Eugene Parker. Who is Eugene Parker, you might ask? And I do have a little Wikipedia thing here. Eugene Newman Parker, born June 10, 1927, who has passed away March 15, 2022, was an American solar and plasma physicist. In the 1950s, he proposed the existence of the solar wind and that the magnetic field in the outer solar system would be in the shape of a Parker spiral. And let me just bring up a couple of pictures I've got of Eugene. There's an early shot of Eugene pointing at a solar flare. Here is another shot of Eugene, a little bit older, near a blackboard with lots of maths on it. Parker obtained his PhD from Caltech and spent 4 years as a postdoctoral researcher at the University of Utah. He joined University of Chicago in 1955 and spent the rest of his career there, holding positions in the physics department, the astronomy and astrophysics department, and the Enrico Fermi Institute. Parker was elected to the National Academy of Sciences in 1967. In 2017, NASA named its Parker Solar Probe in his honor, the first NASA spacecraft named after a living person. So we go back to the image there I first showed, and that is the probe that before it was launched, I suspect. Going back to the article in question, here, Eugene Parker, pioneer of theoretical solar and plasma astrophysics, again was born June 10, 1927. Parker revolutionized the field of heliophysics, notably by first proposing the existence of the solar wind, a stream of charged particles ejected from the sun. In 1958, his theory was confirmed by Mariner 2 in 1962. Among many other achievements, he also predicted the spiral structure of the sun's magnetic field and contributed to theories of coronal heating and the magnetic fields of galaxies and stars. And in 2017, NASA renamed its Solar Probe Plus as the Parker Solar Probe in his honor. The first instance of a NASA space mission being named after a living individual. Of course, then Parker passed away 5 years later in 1922. And so Eugene Parker visits, in this particular image on the screen right now, Eugene Parker, must be the old fella just standing there, with the lady talking to him and pointing to something. Eugene Parker visits the solar probe that bears his name in the clean room, where it was being built in 2017. So it's quite a good shot, that actually. And I've got a couple of other pictures of Eugene here, with the background there, mission to touch the sun, and probably one of his final images there too. Oh, hang on, let me go to there we are. So Eugene Parker, what a career he would have had. All right, let me see, next article, keeping an eye on the clock here. Entrepreneur, courtesy of space.com. This is just a short article. An entrepreneur wants to build a giant net to catch spacecraft landing on the moon, but can it be done? Published 20 hours ago. And here's a little horrible looking graphic, black and white graphic, which I'll put up there. There it is. Just briefly, this novel idea could become an important piece of a future moon economy, it says here. A Greece-based entrepreneur has a unique idea for moon-bound deliveries using a giant net to catch packages launched from lunar orbit. Oh dear. Although there are still many hurdles to clear, I don't doubt it, the system would address many of the key challenges for moon-bound deliveries and could aid in the future mining of lunar resources. Right now, lunar landers are costly, especially when they fail. Rather than using landers for deliveries to the moon's surface, somebody by the name of Cosmas Caris Cosmas, has developed a concept called the momentum absorption catcher for express deliveries on non-atmospheric somata. This is an acronym. This is turning into an acronym. Momentum absorption catcher for express deliveries on non-atmospheric somata, 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 and the acronym is Macedonas. Macedonas. Jeez. It works like a butterfly net on bungee cords. The Macedonian system consists of two elements, the catcher and the deaccelerator. Cosmos told Space.com, after the catcher intercepts the package, the attached deaccelerator slows the package until it reaches the landing pad. Good grief. With this idea, Cosmos wants to solve a few issues. When a lunar lander ascends to the surface of the moon, it uses rocket propulsion, which shoots up moon dust and regolith. This highly abrasive dust can damage spacesuits, spacecraft, and equipment. But with Macedonas, regolith won't be kicked up during landing. Macedonas is also economical, Cosmos said, because it doesn't use fuel, and because there is no fuel requirement, there's also no propulsion system. So Macedonas has more room for whatever is being delivered. It will triple the efficiency, he said. I won't go any further with that article. It does go on a bit more, but I'll just leave it at that. But that's courtesy of space.com if you want to read that. I think it's under the... I'm not sure which tab I've got that actually. Oh, it's no, I'm not sure what tab it's under. But anyway, an entrepreneur wants to build a giant net to catch spacecraft landing. I don't see it ever happening. All right, you're tuned to ASV Radio, VK3 Echo Kilo Hotel. Now, one last article before we go into... Oh, there's two more last articles, apart from space weather. This is potentially interesting as far as I am concerned. Well, let's cut to that picture. And the A2V repeater is kicking back on, but it's just very... for some reason, my signal on 23 centimeters must be a bit poor into the repeater for some reason. Anyway, it's just telling me that it's just on the threshold. This article is to do with giant jets bigger than the Milky Way Milky Way seen shooting from a black hole. Right. Now, this picture you're seeing right now on these two streams is an artist's impression, of course, but nevertheless, a supermassive black hole in the early universe has been spotted blasting out powerful jets of plasma that are at least twice as long as the Milky Way is wide. Its host galaxy is a quasar called J1601 plus 3102, and we're seeing it as it was less than 1.2 billion years after the Big Bang. It spans 215,000 light years from end to end. This is the largest structure of its kind seen in those early stages of the universe's formation, and astronomers think it can answer some questions about how they grow. They say, we were searching for quasars with strong radio jets in the early universe, which helps us understand how and when the first jets are formed and how they impact evolution of galaxies. Jets are particularly interesting supermassive black hole behavior. Jets are a particularly interesting supermassive black hole behavior, full stop. When there is enough material close to a supermassive black hole in the center of a galaxy, it swirls around, forming a disk of material that feeds into the black hole, drawn in by its extreme gravity. That feeding often produces a quasar, blasting with light as the swirling material is heated by friction and gravity to temperatures of billions or millions of degrees. Not all the material falls onto the black hole beyond escape, though, some of it gets diverted along the magnetic field lines outside the event horizon and accelerated to to the black hole's poles, where it is launched into space with tremendous speed. These eruptions of material form jets, and they blast out into space for huge distances. The longest we've found to date are 23 million light years from end to end, much later in the lifetime of the universe. They say here, however, they only emit light in radio waves, which makes them a little tricky to see. To identify J1601 plus 3102, the scientists had to combine observations from multiple telescopes, including the Low Frequency Array telescope in Europe, the Gemini North in Hawaii, and the optical Hobby Albury telescope in Texas. Albury. Yeah, so these observations didn't just reveal the extent of J1601 jets. They allowed the researchers to study the black hole. The amount of light emitted by the quasar activity can be analysed to reveal the black hole's mass. There's another image here too, which I think's a real image. Finally, just two more paragraphs. It's just 450 million times the mass of the Sun, a relatively modest size for a quasar black hole, and it's not scarfing down matter at a particular high rate either, they say. These properties suggest that quasars could be more varied than we generally assume. Interestingly, the quasar powering this massive radio jet does not have an extreme black hole mass compared to other quasars. This seems to indicate that you don't necessarily need an exceptionally massive black hole or an accretion rate to generate such powerful jets in the early universe. Just in case, let me just do this for a second. Just doing a quick scan of an article here. I won't worry about it right now. All right, so that article was courtesy of sciencealert.com. Giant jets bigger than the Milky Way seen shooting from a black hole. Damn, I rely on my TV repeater to see what I'm putting out. I'm just exclusively relying on the computer screen right now. All right, since Tamitha's report goes for 16 minutes, I'm going to go straight to Tamitha. So let me just bring up her caption card. There she is in all her character. And let me just queue up her video, which is somewhere here. There it is. And let's segue into Tamitha's latest space weather report. I better put my headphones on so I know the audio level is not overdriving on 80 metres. Right, 1, 2, 3, 4, 5. Okay, stand by for Tamitha. Hang on, let me do that.
We have an Earth-directed solar storm that's part of a big filament launch that's larger than you might think. And a new region that's emerging on the Sun's far side is about to rotate into view. Those stories and more are in this week's Spotlight. If you want to learn how weather from our star causes impacts at the Earth that shape the future of our world, join Professors Dr. Jenny Meehan, Michael Cook, and myself as we guide you through a space weather certificate program like no other. To enroll in the Space Weather and Environment Science program offered at Millersville University, go to millersville.edu/SWEN. It's weather for the 21st century. This forecast also sponsored in part by CW Ops. Space weather this week is sure giving us some interesting eruptions to look at. As we take a look at our Earth-facing disk, we're going to first say goodbye to region 4100 and region 4099. You can see its glow right there. These two regions have been big flare players, and they are continuing to be active on the sun's far side, but we'll talk more about those in a minute. First things first, let's talk about region 4105. This is the big flare player in Earth view at the moment. And along with this filament right here, boy, it's sure been up to some very interesting acrobatics. We also want to pay attention to this prominence down here, because believe it or not, you'd think that this prominence would just kind of launch off to the southwest. It does something pretty amazing. In fact, as we begin to move this, you can see region 4105 beginning to fire off some bigger solar flares right there, and that really begins to destabilize this. In fact, the top part of this filament actually already just launched off and is moving off to the northeast, but the bottom part of this filament is still thinking about it. In fact, the prominence down here too starts really getting active. So as you watch this here, watch it launch right there, but watch it, look what it does right off to the front there. Let me back that up so you can see. Look at this thing. You would think this thing would just go to the south, right? But it doesn't. Watch this little arm right here go across the sun in front and out that way toward the east. That tells me that likely this filament that's in the process of erupting, you can't really tell. I'll show you a better view of it in a second. But this filament is erupting, and at the same time, there's some type of connection going on between this part of the filament and what was in the filament here, which is really a prominence because you're looking at it from the edge. But this structure is all kind of launching out this way. Now, let me switch it to a different wavelength, our blue sun, so you can really get a better feel for what's going on. The blue sun will enhance certain features so you can which it makes it easier to see. First, you can see that filament. This is the top part of that filament. This thing begins to lift off right there. You can see it's kind of gone. That is what helps launch everything to the northeast, and we'll see that in coronagraphs. But this part of the filament is still hanging on. And yet, as it goes, you'll watch right here, watch these two ribbons. Look at this. Do you see that burning right there? This is evidence that's scarring from this filament that lifted off the sun. On top of that, we also have a dimming region developing in here, which we didn't have before, and a bit of a dimming region here. So you have two dimming regions on either side of these scars. Let you know we've got something, and this is right in the middle of the Earth strike zone, so something is definitely coming right toward us. On top of that, you might notice this coronal hole now has a new finger right in here. With this newly developed finger from this eruption, we'll see whether or not this stays, because if this stays and we get fast solar wind from it, this could mean that the fast solar wind is going to hit Earth harder just because of the shape of the coronal hole. So we'll talk more about that maybe in a bit, but we're going to keep our eyes on it. Now, what does this look like in coronagraphs? As we take a look in coronagraphs, you can see it right here. Here we go. This part is that northeasterly launch from the top part of that filament that let go up here. Okay, and you can see here, this is region 4110. This is the whole region why this thing got destabilized, but we'll talk more about that in a sec. So that's the first part of that filament launch. As the bottom part leaves off, you're going to see here, there's where it's kind of growing. But remember, that finger thing goes in front of the sun off from the west side to the east side of Earth. So you watch this eastern edge here just continue to move all the way out to the point where this halo is like almost 180 degrees. This is actually a serious part halo right here. Now, granted, we got a little bit of a solar storm. It's a separate solar storm launch there, but nonetheless, this is quite wide. And so there's got to be something that is coming toward Earth. Now, whether or not that's actually going to give Earth a decent impact or not, well, it's looking like it's moving very, very slowly, and so likely not going to give us a big impact in terms of storm strength, but it sure would be nice if we saw some clear signature of something, because this is an amazingly big structure that we're looking at. And on top of that, as I'll show you, on the sun's far side, there's part of a filament that is burning on the sun's far side. So it erupted as well. It was likely part of this structure in here. So this thing is literally a filament kind of joined structure that wrapped almost completely around the sun. Just absolutely phenomenal, the types of structures that we see coming off our star. Anyway, okay, so on top of that, I want to show you, you'll see a launch right here if I caught it in time. Yeah, let me back up just a smidge. I knew it was right after the coronagraph. See this? So you see like an evacuation of something right here. Watch. Whoosh, right there. That is region 4099, still launching solar storms. So we're going to be paying attention to it on the sun's far side because that one is still becoming a big deal. But a little bit more importantly, as I switch colors here, you'll see these jets of stuff coming off. Look at how strong these jets are. Not only is this region 4111, but you'll see we also have another region that's new. And I'll talk more about that as we move into the full sun map, and this thing is likely going to be causing solar flares to boost here over the next week. And now switching to our full sun map, we are taking a look at SDO AIA data on the sun's front side. That's what's in red, and solar orbiter EUI data from the sun's far side, because solar orbiter is actually looking at the sun's far side right now. So we have a nice view of the entire sun at the moment. So as we take a look at this, I'll set this in motion. You can see we actually have region 4100 and 4099 as these begin to rotate to the sun's west limb. From Earth's view, that should calibrate you. And then on the east limb, I know it's a split screen here because we got the far side in the way, but here's region 4105, and you can see this filament here. I want you to take a look somewhere in here, and I'm trying to remember exactly where it is, but watch this. You'll see this. Oh, here it is. You'll see this big filament. You see this long filament right here? Watch this thing begin to erupt on the 7th. And it's really slow cadence for solar orbiter data, but you will be able to see. There it is. Look at this. Do you see this set of ribbons? Look at that. This set of ribbons on the sun's far side correspond to the same time we had the ribbons burning on the front side in the emergence of region 4110. So this filament that's on the sun's front side that I just went over and talked about, right, that erupted, and then we had a prominence eruption that kind of wrapped it to the southern pole, and then it wrapped it all the way around to the far side of the sun. A massive filament launch on the far side. All of these, I believe, are connected. This is an insanely large structure that ripped off of the sun and did it in multiple parts. So if anyone studies the synoptic field of the sun, oh my gosh, you know, the whole thing, it's amazing to think how well the sun can be connected from very large longitudes and latitudes. So besides that, let's talk a little bit about what we're seeing here. Notice we are seeing a new region. As a matter of fact, I'll back up just a little bit so you can see right before it comes in. So we have 4111 that's beginning to enter into the east limb, right into Earth view. But we also have this new region. I'll back up just a little bit more. So over the last 24 to 48 hours, this is where it was. You watch it grow. Okay, well, I've got the marker here, but look, there it is. It's growing big and fast. So not only do we have region 4111, but we also have a region right behind it. And that's why when you look at the sun's east limb, it really looks kind of complicated with lots of stuff. Likely this is the region that's firing off a lot of those big jets. So get ready. We could see some big solar flares here over the next probably 48 hours, I'd say, for that thing to fully rotate into Earth view. Not a lot going on after that, but I would think that this cluster of regions is going to keep us quite busy for some time. So amateur radio operators and emergency responders, well, enjoy the DX you're getting right now and the quiet noise, because the noise floor is likely going to rise here in about 48 hours, and we could see another week or possibly 2 weeks of intermittent radio blackouts. And now returning to that Earth-directed solar storm, I'm taking a look at our solar storm prediction model, ENLIL. This is NOAA's version of the model. The top panel's density, the bottom panel's velocity. You're looking down at the sun from the North Pole with Earth being off to the right. Now, when it comes to the solar storm model, the Earth-directed solar storm is just really the first part of that filament eruption. So not expecting this, even though we're going to follow it for the potential arrival time of this very slow solar storm. As you can see, it's very slow. It arrives at Earth sometime about midday on the 12th, according to NOAA SWIPSY. Am I expecting an arrival time faster or slower than that? Probably not. It's probably going to be sometime on the 12th. I'm not going to put a tight margin on it. If we switch over to NOAA's version of the model, here's NOAA. Again, you're looking down at the sun from the North Pole with Earth again, you're looking down at the sun with the North. Again, you're looking down at the sun from the North Pole with Earth being off to the right. And when I set it in motion, you'll see this solar storm launching once again, kind of weak and to the north of Earth, they're expecting impact to be sometime around, maybe early on the 12th. NOAA is expecting it to be later on the 12th, so just sometime during the 12th. It's going to be a big uncertainty. But I do think the solar storm is not just going to hit north as like this impact footprint shows. I really do think that the solar storm is going to have a much bigger Earth component to it. So it's going to be more of a direct hit. But again, not expecting it to have a huge impact because it's just not moving all that fast. So aurora photographers, if you're at high latitudes, you never know. If this thing has the right magnetic orientation, it could give you a decent show. It's just not going to be something that will likely spread down to mid-latitudes all that easily. I have been wrong in the past, so we shall see. But aurora photographers, if you're at high latitudes, it might be worth a look. Now, switching to our moon, we are passing through the full moon phase, with the full moon being on the 11th, and by the 16th, the moon will be about 74% illuminated. So you night sky watchers, if you want to catch those dim objects in the sky, like, I don't know, maybe some aurora, well, you're going to have this bright companion, so you're going to need to check your local rise and set times. Now, switching to our solar storm conditions and aurora possibilities over the coming week, we are anticipating to hit from that Earth-directed solar storm. It's not moving very quickly, but it could be a big storm. At high latitudes, NOAA's expecting minor storm conditions. We have up to about a 50 to 55% chance of a major storm, and that's going to be from a combination of the solar storm impact and a bit of fast solar wind. So aurora photographers, if you're at high latitudes, I would expect around the 12th is really when you should be looking, but we could see it hit even on the, into the 13th before things begin to calm down. We'll have a little bit of fast solar wind after that, but by the 15th, things should have settled back down to unsettled conditions. And now at mid-latitudes, while we're only expecting unsettled to active conditions, again, we're not expecting a big impact from this Earth-directed storm, but we could see up to about a 30% chance of a minor storm. Again, NOAA would expect the impact to be more on the 13th than on the 12th. I'm still keeping it on the 12th just to be sure, because it might be a little bit bigger and faster than we anticipate. But by the 14th, things should be settling back down, not expecting a lot from this fast solar wind chaser. So aurora photographers, only if you're dedicated should you chase at all, especially because I'm not going to expect a lot from this particular storm. Now, as we switch to our solar flare and dayside radio blackout outlook over the coming week, we are going to be seeing a rise in the solar flux, and this is mainly because of those new regions 4111 and the region behind it. These are definitely bigger flare players. NOAA's expecting moderate noise on the bands all week. I think that's about right. We're going to start around 35% chance of M-class flares at an R1 to R2 level radio blackout, and only about a 5% chance of X-class flares. But that could rise to about 40 or 45, possibly even 50% chance of those R1 to R2 level radio blackouts by the end of the week. And that's because of these regions rotating into Earth view. We might even see a rise of to about a 10% chance of R3 level radio blackouts. So amateur radio operators, expect to see that noise on the bands begin to rise again over this next week. It looks like the respite is over. And now switching to our radiation storm and polar aviation outlook over the coming week. Everything is in the green this week. We are sitting at the D1 normal range. This is for you aviators at flight level 360. It's also the S0 quiet range for everyone else. We're only expecting about a 5% chance of an S1 to S2 radiation storm, at least over the next 3 days. We could see that rise a little bit, especially as region 4105 begins to rotate to the sun's west limb. Not expecting much of a rise, but possibly up to about a 10% chance of risk. So you frequent flyers, and this does include air crew and high-risk passengers, right now you're all in the green, but again, be sure to pay attention to those ICAO advisories, because those new regions in Earth, or that are rotating into Earth view, could make this pretty picture change very quickly. So the space weather this week has given us a lot of interesting things to look at. We do have an Earth-directed solar storm that's on its way. Now, it's likely a very slow storm, but it could be big. So aurora photographers, if you're at high latitudes, you could likely get some kind of show. Aurora photographers at mid-latitudes, well, probably want to sit this one out, to be totally honest. Now, amateur radio operators and emergency responders, well, it looks like that wonderful low noise floor is going away here over the next 48 48 hours, we're going to start seeing bigger chances of radio blackouts again, and that could last for another week. So just expect the noise to come back and kind of hunker down as we get through this next rough patch. And now you GPS users, well, GPS reception on the day side is pretty good right now. You might see it get a little bit worse as the new regions rotate into Earth view. So pay attention at dawn and dusk, because that's where your GPS reception will suffer the most. But outside of that, it should be pretty good. I'm Tamitha Skov, the Space Weather Woman. Thank you for watching.
All right. Thank you, Tamitha. Let's just go back to camera here. All right. Good evening, everyone. Well, that was an excellent report covering the weekend, up to the weekend. So it all should be fairly accurate to some degree. Anyway, thank you, Tamitha. Yes, I apologise for the ATV repeater. I've been, during that 16 minutes, I've been trying to reset the system here, but it's a little bit hard when I'm in the middle of doing a program, because it can upset the processes a little bit. So I can only put it down to just atmospheric conditions between here and the repeater playing up a little bit. It's down to 3.7 degrees at the moment, so there might be, I don't know, there might be something. I've checked the radar, and there's certainly no rain falling anywhere that could be causing a problem right now. Anyway, there it is. But I can see that there's about 10 people watching the YouTube feed, which is good. So at least they've all QS-wide to the YouTube. And I can see there's only one person on the Discord. So we usually get about 4 or 5 people on Discord, but that's been very quiet tonight for some reason. Okay, I'll just quickly finish off with what the spaceweather.com is reporting. This is the current disk of the sun, if we could look at the sun right now. So there's several sunspots on the sun, and let me bring it up. There it is. The solar wind is currently at 430.9 kilometres a second at a density of 11.31 protons per cubic centimetre. The radio sun, measured at a wavelength of 10.7 centimetres, is 142 solar flux units, as it's pretty high. The corona, and the aurora, I did have that up a moment ago too. This is the current aurora australis, beaming its way towards Tasmania and the mainland. So, like I said at the beginning of the broadcast today, there was definitely some auroral effects occurring, I would say. The coronal hole is fairly evident, and lots of charged particles streaming from that hole as well in the coronal. All right, and the KP index, the planetary K index, is currently 5.33, and that's considered storm conditions. Over the next 24-hour max, KP will be 6.33, also considered storm. It's rare to see the planetary K index actually indicating the storm conditions, but going by the aurora at the moment, I'd say that would be quite evident. So the report on spaceweather.com, pretty much what Tamitha has been saying. On Friday the 13th, geomagnetic storm arriving early than expected, hits the Earth's magnetic field on June 13, sparking a G2 class geomagnetic storm. There is a chance that it is ongoing. The ongoing storm could intensify to a category G3, which is considered strong. Right. Okay. And that's about all I can report there at the moment, I think. And I won't worry about that, the rest of that. So there it is. And finally, as of June the 13th, Friday the 13th, 2025, there were 2,349 potentially hazardous asteroids, but none of those are on a collision course with Earth, so we don't have much to worry about. Okay, well, that was a very quick 60 odd minutes. So I shall finish up there. And just to give you a view up at our dark sky site, there's the all sky camera. We have an all sky HD all sky camera up at our dark sky site up at Heathcote. And as you can see, the moon is in full flight. So, as Tamitha was saying, we're just coming out of the full moon. And but the moon is still a very bright source in the sky right now, and it makes doing any observing a little bit difficult with that all that light. But that's the current view up at LMDSS, Liam Mayo Dark Sky Site. All right, this has been a broadcast from VK3EKH, the official station of the Astronomical Society of Victoria, with a regular Friday night broadcast here on 3541 kilohertz and elsewhere. Again, apologies for the ATV repeater, Melbourne TV repeater, for dropping out. I don't know quite what's gone wrong there. But we have been YouTubing and also on the HD stream on my Discord. On that note, I shall go across to 80 metres and see if any stations wish to check in. Let me just get my piece of paper here ready to write down. And yep, alright, does a pen work? Yes, it does. Good. So this is VK3EKH listening on 3541 for any stations wishing to check in. Alright, we've got VK3GL, VK3DX, VK3SPX, VK3AOB. Anybody else? Alright, take it, Graham. VK3GL, VK3 EKH. Yeah, no worries, Graham. VK3GL, VK3EKH returning very good. And you're also a bit more than 20 over 9. But I can tell you're on the FT7 because you're slightly off frequency. So I was gonna say that you're on the FT7. Anyway, that's all right. Thanks, Gray. And we'll no doubt catch up at some stage tomorrow with the other project there. Okay. I can hear myself. Oh, yeah, I'm monitoring myself on my mobile phone. There we go. Okay. Across to there, Greg, VK3DX. We haven't heard you for a few Fridays now. I guess you've been otherwise engaged. VK3 Delta X-Ray, VK3 EKH. Clint.
Thanks for running it there and doing a great job, as you normally do. And good day to Graham there, VK3EL, and good day to Britt, VK3AOB, up there at Leonard. All signals have been very good. The conditions are very good on 80 metres at the present time there. Clint, that's for sure. Okay, mate, one hold it, all good, and we're back at Friday night. Back to you there, Clint. Thanks for running, mate. VK3 EKH, VK3 Delta X-Ray, Greg in Warrnambool.
Yeah, thanks, Greg. VK3 Delta X-Ray, Warrnambool, VK3 EKH returning. Warrnambool. No worries, Greg. Yep, your absence has been noted, but that's okay. Like I say, in the past, the stations that check in here on the broadcast come and go, and it's fine. It is the footy season, and I know a lot of people sit there and watch the football and get thoroughly enthralled. I'm not sure which team won tonight, but they were pretty close. The last time I checked it was in the 30s. 30 goals, and they weren't too far apart, and I think there was about 14 minutes left of the game, and I thought, my God, that's a low-scoring game, but I guess somebody won. Anyway, that's another story. I'm not too worried about that. Thanks, Greg. Good to see that you're still with us and fighting strong. Good signal here into Narre Warren. Not a problem at all. Steve, VK3SBX, VK3 EKH.
Do this sort of work on the moon. And the job is what we call foundation constraint-driven design, amazing minds, and that we need to orient in really tricky environments. We've created 4 prototypes over the last, within 12 months we did, and you can see that's the demonstration of the rover operating autonomous, or not autonomously, but remotely operated from Denver down to Japan. Mobilization phase. We are shortly.
So Jared from Lunar Outpost as well.
What was the which launch?
Indulging us and working with them getting to come
that you haven't heard about. What was it again?
I know it was a pretty short notice and a lot of work behind the scenes, and I want to thank Jared for the time spent with me at Offspace talking about Rover and working with me to get you to come on and give this talk. It's been wonderful. Really.
Yes, I know what you're saying.
There's two words that I use for this. It's a wonderful privilege. It really is.
No, I haven't.
And everyone that works
mute
on
that.
this.
Hang on a sec.
This is certainly not something, when I'm
there.
talking about.
I'll go back to me. Oh yeah, sorry about that. I didn't mute the audio. I was running the talk from Ben Sorensen last Wednesday, so that the audio was running on top. Oh, I can hear it. So I'm hearing it through my mobile phone, which is delayed. I'm getting confused. Good question, actually, Steve. I can't say that I've heard anything from that. I do recall a rocket on a launch pad. They were getting ready for a launch. Yes, I remember seeing that somewhere. But you're quite right. It's gone quiet. I wonder why. All right. Well, maybe I can look into that, and if I remember, we'll bring that up next. We'll find out what the latest is with our own space centre up there in Queensland, and see how that's going and what's been going on. So yeah, interesting indeed. All right, not a problem. All right, thanks, Steve. Good to. I'm glad you were there. I noticed that I didn't see Andrew come up on Discord. I've only seen you sitting there, but we do normally get about 4 other people, so it's been very quiet tonight. I'm blaming it on the cold conditions. It's 3.7 right now, so it's going to be a frosty morning. Oh dear. Anyway, never mind. All right, thanks, Steve. Britt, VK3 AOB, VK3 EKH.
The sun's interesting. The WA, West Australian SSTV blokes have a scan every 4 o'clock their time, every day, 6 o'clock our time, and VK6ATI came up. He runs it. Tony's his name, and he gave a call, and I don't think there was anyone there, and then I spoke to him briefly. And anyway, I ended up cancelling. Due to all that solar wind stuff that you were watching earlier, that explains why the band is not very good. This afternoon on 40 metres, a couple of guys up in Sydney, I was exchanging pictures with them, but quite a bit of noise through them, so you can sort of tell that it's something is amiss, not their normal strength, but it's interesting stuff. The sun it has more of an effect than you'd realise. So it's interesting. I notice at night I get into bed, and some nights of the week I'll listen to 3MP from which I can receive up here. I've got long wire strung up, and I've got a PK loop antenna as well, and it plugs. And I've sort of plugged it into that. It gives it a little kick in the butt, and you get quite a good signal. But there's some nights where it's pretty poor. You'll have the other 1377 station, which is somewhere else up north, that might be coming in, and the propagation's wishy-washy. So I tuned to 1323 kilohertz, which is Adelaide Cruise. It's station, the transmitter's up at Crystal Brook, and you get that quite nicely. But yet now, a couple of nights later, the tables are reversed. So the sun and the solar wind has quite an effect. Anyway, it's been a good broadcast. I won't hold you up any longer. I'll get lost, and maybe next week. So back to you, VK3, VKH3 AOB.
Yeah, good on you, Brett. VK3 AOB with a superior signal, VK3 EKH. No worries, Brett. Yeah, look, I used to, well, I can still do it. I've got all these comms receivers around here. You can I'm not sure if you're watching the YouTube feed, but there's a rack behind me that's got a whole lot of receivers in it. And when I get this shack set up the way I want it to be, I'll definitely be having receivers all running around here. But I do the same. I have done that in the past as well. Listened to distant AM stations, and always noted the variations in signal. Always nice to listen to a distant AM broadcast station fading in and out with a little bit of music running in the background, perhaps. Yeah, what was I going to say? The other thing, it's often interesting to experiment with remote SDRs on your own transmissions. Because I come up on the coffee break net, the 11 o'clock coffee break net on 1825 every morning. Well, at least if I'm at home, I do. But with the regular coffee break stations, it's interesting to listen to tune into various SDRs just to see whether at 11 o'clock in the morning where the carriers are being detected. And there's an SDR in near Adelaide. I forget what they call it right now, but that's about 600 kilometres away from here. But it certainly sees my signal, and most of the stations that come up on the coffee break net are seen on that SDR. Only some of the other stations that are a little bit stronger, you can actually see modulation and can hear it. So it is quite interesting even at that time of the morning. Anyway, all right, enough of that. Thanks for listening, Brett, once again. And we're down to we've got 6 stations monitoring, 5 because one of those is me on YouTube. So thank you for watching. All right, I'll just take one more listen on 3541 if there's anybody else wanting to come up. VK3 EKH listening. Just noise. All right, this is VK3 Echo Kilo Hotel concluding broadcast for tonight. Again, apologies for the repeater for those that were watching VK3 RTV. I know there's at least one out there. So I'm certain what happened. As soon as I finish here, I might do a quick reset of things and see if the problem can be fixed. But otherwise, I'll leave it alone. Try and get to bed early. This is VK3 EKH concluding the transmissions for night. Have a nice weekend, everybody. Stay warm. We'll see you all next Friday. Take care. This is VK3 EKH concluding. Cheers, everyone.
Thanks for that, Clint. Cheers, mate. Thanks, Clint. VK2. Yeah, cheers, Clint. No worries. Yeah, Greg, how you going? Got the 6 metre repeaters. Doesn't seem to be running on Mount William at the moment. Yeah, Roger, Brett. Brett, I believe, I'm not sure what's going on, but I believe it's not working there.